Welcome to another episode of the Stellantis Tech and AI podcast. I'm Dale Jewett, your host. And in this episode, our guest is Paola Baratta, who is Stellantis' Test Center Manager in our Propulsion Systems Group. Paola, thanks a whole lot for joining us today.
Hi, Dale. Thank you.
And it's another one of our fun long-distance podcasts. I'm sitting in the Detroit area, and you are in Europe. Can you tell me a little bit about your background, Paola?
Okay, Dale. I spent around 24 years in our company, and mainly in the powertrain perimeter. And I started in the Fiat Research Center in Orbassano as a young engineer in advanced team for diesel engine. And then I spent many years in calibration as team leaders for after treatment calibration, both for passenger and commercial vehicles. Then I had some years in program coordination, so as the chief engineer for the 1.3 small diesel engine. So again, diesel engine in my life for a very long time. And in the latest 6 years, I joined the testing and analysis team, taking care of the testing facilities in Italy, with the goal and commitment to move from conventional testing to electrified one.
Tell me a little bit. Your background is very engineering focused. What was your interest? How did you get into engineering?
I don't know at the beginning why I chose such kind of degree, but I'm very curious. And so this is probably the main reason. I'm rational, and I was very engaged in combustion. Then I changed totally, and now I am on electrification. And this is a really new challenge for all the team, and it makes my job every day changing, and this is good.
Were you really interested in cars growing up? As a teenager, did you play with cars or work on cars?
Not playing cars, but looking at engine, because my father was working on engine at home in the garage, and I was curious on that.
I'm curious, what was your first car?
My first car was a Citroen. So a Stellantis one, I can say now, a very, very small Citroen.
Yeah,
LMA.
I'm sure you have a lot of great memories of that car.
Yes, I have.
Excellent. Well, let's talk today about your work in electrification and batteries. Why don't you start by giving us an overview of the battery technology centers?
We start 4 years ago as investment request. We achieved the investment was approved. We are speaking about 40 million. And then we spent 2 years in realizing and preparing the building, installation of the equipment, and the battery technology center start operation last year in September. So now is the 1 year that we are operating the lab.
The goal of the tech center, I understand, is to help us improve and develop battery technologies. When it comes to that, what are we looking for from a battery that needs to be able to work inside a vehicle? What are the key elements?
Okay, there are many elements. One of them, the main one, is the chemistry, for sure. No, so and it is the focus for new technologies and for advanced activity. But on top of that, that is for sure the core of the packs, the battery. We have also many additional elements as a system, at system level. So we have the cooling, we have the reliability, the aging of the components, and all the aspects that are customer related. No, I mean the reliability of the pack, the charging time, and all the performance that are customer oriented. We need also to develop the battery management system, because we have a control of the unit and a complex software that have been developed, that need to be developed and tested. So we perform both tests at component level, but many tests at the system level.
Okay, so I'm certain that the work that you guys are doing in your test centers have a lot to do with what benefits our consumers. What are we trying to accomplish as we're developing new batteries?
We are trying to increase for sure the range a lot. We are trying to reduce the weight of the pack itself, and we are trying to increase reliability in terms of performance. So these are the main three goals. But on top of that, we have also all the environmental aspects, and also the, for example, how we produce specs in a sustainable way and in the more effectiveness way to be affordable for our customer.
When people talk about the future of battery technology, particularly for vehicles, a lot of it seems to land on solid state battery technology. We recently chatted with Marty Jagoda in Stellantis because we've had an announcement with our partner Factorial in wanting to get a demonstration fleet of solid state batteries. How is your work impacting what we want to do or what the industry is heading for with solid state battery technology?
But for solid state battery technology, we had, as you said, we had a lot of. We think that it is that they can play a crucial role in the new electrified vehicle. Now, more related to material stability, and but we had a lot of challenge to be able to install such a new technology on our vehicle. I mean that we need to face all scalability of production, cost, manufacturing cost reduction, and we need to investigate and demonstrate longevity of this new technology as the cycle life. So in our battery technology center, we checked and tested this behavior. We need to verify the long life, we reproduce the life cycle life of this component on the vehicle. We reproduce all the performance, but also all the condition on road of these packs, cell, module, and packs, to demonstrate and to tune these new technologies in the system to be able to achieve all the goals that are related to the performance for customer usage of the vehicle.
There seems to be a real wide variety of chemistries for EV batteries these days. A lot of different technologies, from the traditional lithium ion to sodium batteries, and again, we're talking about solid state batteries. Does having such a wide variety of options, is that a challenge to the types of testing that your teams are working on in the battery centers? Do you have to change your test cells if you're putting a different type of chemistry into a test?
No. The center has been designed to be able to test any type of chemistry. And so in our 8 climatic chambers devoted to the cell testing itself, we are capable to test any kind of chemistry. And currently we are going to start activity on Factorial components. And in the past, we already tested the solid state batteries for Polytechnic of Torino, for example. No? So we tested, checked, and tested, performed tests on ACC components, for example. So all products that are both in our Stellantis vehicle, but also in the future as advanced the program. We don't need to change any equipment, both for chemistry and for, let me say, size of performance of pack. Because when we designed 4 years ago the labs, we tuned the equipment to be able to face a new challenge and a new performance of the packs. Both in terms of performance, in terms of size. For example, we are capable to test both Stella Small, and last week we received the first proto of Stella Small battery packs, but we are also capable for Stella Frame. So Stella Small, Stella Medium, Stella Large, up to Stella Frame. And this is just to avoid to have a very tailored equipment, but not able to face future opportunities.
That is a wide variety of battery packs that you're testing. For some of our listeners who may not be really familiar, could you describe what is the testing regimen of a battery pack like? I mean, do you just sit there and watch it and try and measure how it discharges?
Okay. Oh, we did a lot of different tests. Now we perform charge and discharge of the pack for sure. Now to reproduce vehicle functionality and both in charging and discharging. And we did different tests, very short tests that reflect the performance of the packs, or very long tests up to 18 months to be able to verify the stability for a life cycle of the packs. You can consider that 18 months of testing activity reproduced 15 years of packs on a vehicle. And this is our goal. Then we perform also special tests in climatic condition as thermal shock test, both up to starting by minus 40 degree up to 60 degree in very fast transient condition, up to 20 degrees per minute. So very, very shock thermal test. Then we perform BMS, so the software validation in terms of development and debug of new software to monitor and to manage the battery pack itself. We perform also tests at module level, so components level, and at cell. This is all in climatic chambers. And we perform after the testing or during the testing phase, we perform also some rework of the pack because we are speaking of proto, and so sometimes we need to change some components during development. And we perform the tear down of all these components at the end of the test to verify the status of the component. We are also capable to perform benchmarking activities, so open and look at competitors' components to learn and to compare our product to others' products that are on the market.
Paola, I'm no engineer, but my understanding is EV battery packs are a lot like humans. They're really happy at like 70 degrees Fahrenheit, or I think it is about what 15 degrees C. In our testing, are we making progress in extending sort of that envelope of where EV batteries can offer their better performance? The automobiles live in probably the harshest use case environment that you can think of, from the hot weather of the deserts all the way to, well, in Detroit, the very cold winter, right?
Yes, and we check all these conditions for sure. For example, you can have a car in a garage at 10 degrees and go immediately outside at minus 40. It can happen. And it has to be managed at conditioning level because, as I said before, in the vehicle, we have the conditioning of the unit. And in our chambers, in our testing chambers, we reproduce both the conditioning unit that is present in the vehicle and the environment, both condition, to be able to reproduce and emulate what will happen to our customer.
Okay. Well, hopefully, maybe the answer is just to put more coats, more blankets on the batteries in cold weather states like Michigan, and cool them better in the summer. In addition to just developing batteries for electric vehicles, sustainability is an important question, and it's a very important topic to us at Stellantis. Talk to me about how the test center and the work that you're doing is playing into the issue of battery recycling and how we are using sustainable materials in our EV batteries.
Yes. As Stellantis, we are strongly committed to a circular economy approach. So since the design, to the production, we are designing our component to be able to be recycled at the end of life, to consider a possible reuse, second life of the component, or to use parts to manufacture additional packs. So all of these activities are performed internally in Stellantis, for example, in our circular economy hub here in Turin, but there are also many partnerships with the battery recycling system to be able to explore innovative recycling technologies, both for components of packs, but also for scrap from gigafactories, for example. No, because we know that the scraps are one of the issues about battery manufacturing at the moment. And this is very important to stay focused on the recycling and on reusing of components. And all Stellantis packs at the moment are repairable. And this is one important point, one important goal that we expect to be also regulated in the future.
Okay. As opposed to if a package damaged, then you have no choice but to delete the whole pack and just replace it.
It's not. It's for Stellantis packs, we can repair, we can substitute, rework the packs and change only one module, for example, or one cell. And this is very important because it ensures very low impact environment. And this is an important goal to have such kind of component. For sure, on the other side, it's a high cost because it means an important design effort to do it happen. It's possible. And in circular economy, for example, all the components are reworked and not wasted totally at the end of life.
Which is great, because as a consumer, I'd much rather replace a damaged cell in my battery pack rather than the whole battery pack, which is an incredibly expensive component,
Sure.
thousands and thousands of dollars. So it's kind of like in today, I'd rather just replace a water pump on an internal combustion engine than have to change the whole internal combustion engine for a failed water pump.
For sure, such kind of rework will not be done in your own packs. Probably we will substitute your pack, but having a reworked one, not just a new one. And this is something that is, has to be thought in the beginning of the design of the component, for sure.
That's interesting. How much of a role does regulation play in the work of the test center? Especially because our products are sold around the world, and different regions have different regulations for electric vehicles as well as conventional internal combustion cars.
Yes, and we are, let me say, ready to face all homologation in all different countries. And we are working on that. But in the main focus is just for safety. So all the regulators related to fire exposure, thermal propagation, and in case, for example, of a crash test. No, it's clear that regulation is focusing on this aspect that we are for sure able to manage in the future. We already did. And but we expect, as I said before, also additional requirement from regulation in terms of recycling and disposal, because this is an important point for environment, and it is an important choice to at the design level. We need to know at the beginning if it will be mandatory or not. Otherwise, we will have very different product on the market at different cost, and it's not easy to manage that.
So
as a
Paola,
strategic choice.
okay. So Paola, we've talked a lot about battery packs, and I don't want our listener to think that we're only talking about full BEVs. The test centers, do they also pay attention to battery packs that are sized for vehicles such as plug-in hybrids or even a mild hybrid?
Sure, sure. In the lab, we have both versions, for example, still medium, BEV and PHV, and they are at 40% hybrid currently tested at the BTC, if I can say you a number, no? And this is clear in terms of capability of the lab, but it is also clear in terms of workload, because in the future we will have both BEV and PHV and hybrid vehicle. So we will test all of them with no limits, let me say, no special constraint.
Do you have the opportunity, after you've been spending your workday testing battery packs, to go out and drive in an electric vehicle?
I had, even if in my, let me say, in the past, I was really focused on, I told you that I had a Citroen at the very beginning when I was very young. Then I moved to Abarth. And Abarth, not BEV, but standard internal combustion engine. Abarth is very far from BEV, I can say to you. And so very noisy, emotional, but also driving an electric vehicle, a BEV, can give you emotion. Very, very different, far from noisy and internal combustion engine, but you can listen to nothing, to silence, and they are very higher performance for BEV. And I think that now customers are also changing their approach. They are understanding that there is no risk to not have a charging station available. Fast charge can allow us to have a very, very huge, long trip in highway. Also, for example, I can say you that the new, you know very well that new Peugeot 308 can perform up to 1,000 kilometers in high speed, just having two very short fast charge. And it is something that it's very similar to an internal combustion engine. So what was a problem maybe some years ago now is just a good feeling to not have noise and to have a very high performance vehicle.
Excellent. You know, there's a growing industry out there of shops that like to take classic vehicles and install modern EV propulsion systems into these classic vehicles. And it makes me wonder, would you would you feel good if we could go find your Citroën from your teenage years and put an EV powertrain in that for you?
It will be very funny, I suppose, because I can say that when I when I had such car, it was just for the cheaper one because I have no money, and so I chose that just for to have a cheaper vehicle. But now also the design is very similar to a very city BEV car, no, and so it's not so strange. It was very light also, no, because they were very small car. So okay, it's a BEV for sure. It can be.
Yeah, I'm not sure we could put a whole lot of battery into it for you, but
No, very small one. A PHV maybe.
I'm sure it would be a ton of fun. Well, Paola, thank you very much for taking the time to talk to us today about the work that you're doing in our battery test centers and the fact that you're really working on the future for us, the company, as well as our customers.
Thank you very much. Thank you very much for inviting me to this.
You bet. We should connect again in a year or so and see how much has changed.
Could be a lot, I think.
You bet. Fantastic. Well, and thanks to everyone for listening to the Stellantis Tech and AI podcast, where we speak with some of the brightest minds in the tech and automotive industries. We invite you to follow Stellantis Tech and AI on LinkedIn and Instagram and join the conversation. Stay updated on what's ahead and be a part of this community exploring the fast lane of technology and AI in the automotive world. We'll chat with you again soon.